Hi everyone. This test is for the topic that's actually happening at the Over Unity forum, and it's a test to look at the factory capacitor that is built in this generator head, which is a 12 microfarad capacitor. Let's see if I can get that shot upside down there. So you see it there, 12 microfarad. And what I've done is I've done the same thing as what TinMan has done, is I've separated the field coil, the exciter field coil from the capacitor, and I've incorporated 2 meters. This first meter here will be displaying the voltage, and it's set on the AC voltage scale. And then this meter here will be displaying the current, so that's set on the AC current. Well, there's a view of both meters, and they're automatic setting meters, so they just find the range. For load, I will be using 2 precision resistors. One of them is a 10 ohm 1% resistor that's rated at 50 watts. The next resistor is a 5 ohm 1% as well. So these 2 resistors are in series. 15 ohm load is the ideal resistance for getting most power out, with a total of 41 microfarads. So it's still a series capacitor, but all these capacitors come up to 41 microfarad. So that's attached to the output of the generator, which is this side, and this side here is my usual meter that I use for displaying the amount of power that the prime mover needs. So I've got it tuned now so that basically when I flick the switch, I'm going to be pulling out maximum amount of power on those 2 resistors. And so we have a total of 15 ohm load and 41 microfarad series capacitance. And you'll see that there'll be no change in this meter, and I trust this meter because I've checked it before with the scope to see if the same kind of thing is happening, and I've done that video before. We don't need to go back there again. This is good enough for this demonstration, and there is also no drop in RPM and all that kind of thing. What we want to do in this video is just look and see what happens to the exciter field capacitor here as far as voltage and current. So I'm going to go ahead and start that, and on our 15 ohm load here, since it's not a perfectly beautiful sine wave, I'm using a scope probe, and I've got the scope set up ready to go, and we'll be getting our numbers right here at the bottom right here. So that's all ready to go, and we'll show what the power output is on the load, and you can then see what happens to the exciter field capacitor. So without further delay, let us start this prime mover. So the prime mover is operating in the range of, it's always about the same. We're at 158 watt range, maybe 157. The switch is turned off at this time. There's our voltage on the generator. That's not very accurate, that's a piece of garbage. But anyway, now there is the data on our capacitor. 167 volts, 1.4 amps is what's happening in the capacitor exciter coil and capacitor. And nothing is happening there because I haven't switched the switch on. So let's have a look here at the capacitor, and I'll turn on the circuit. So the circuit is functioning at this time. So we have now 125 volts across our exciter capacitor, and just a little fraction under 1 amp. I'll turn off the circuit. circuit is off. Turn on the circuit. So there's the information there. And there is our waveform across our 15 ohm load. And if we look, we have a total of 22.4 volts RMS across our 15 ohm load. And if we look at our current, or our power going to the prime mover, there it is. So we're in the 100, again in the same range, and the circuit is on. I will switch the circuit off. Circuit is off, zero change. Circuit is on. So there you go. And our 22.4 volts RMS across our 15 ohm load comes to, let's see, 22.4 comes to, there's the data. 22.4 volts on 15 ohms is 33.45 watts. So we're pulling out 33.4 watts, and this is what is happening in difference when we pull out that load on our exciter capacitor. Off, that is normal operation, and with the series capacitor circuit outputting 33.4 watts. So there you go. I don't know what that does really, because there would be a lot of other calculations that would need to be done as far as power factor in those capacitors, because most likely it's all reactive there as well. So I don't know what all this means. I'm not an expert. I will let the experts debate about that, and they can decide what is going on. So thanks for your interest, and bye now. Sorry, I just remembered that I forgot to show that there is, let's stop this here, there is heat right there on that resistor. Ooh. So it's not just fake, it's got lots of power really happening right there. So thanks for your interest, and we'll see what the experts come up with. Bye now.